Recording. All right, let's grab, oh, not that. Calculator, there we go. I don't think I actually used it though. So DCA, yeah, finding mins, max, points of inflection, and so on. So let's review some derivatives. The derivative natural log is 1 over cosine of x, and then times the derivative of the inside is negative sine of x. So this one is negative tangent of x, and that's probably, this first part is probably referring to the multiple choice. So look for negative tangent on that one. Derivative e to the x is e to the x, so it's e to the 2x, but then times 2. Derivative of the inside. Inverse tangent is 1 over 1 plus x squared. Exponential is very similar to, that is exponential, except we don't write the natural log of e. So this is 5 sine of x, natural log of e is 1. And then times the natural log of 5. So there's the derivative of the exponential part, but then the derivative of sine is cosine. So cosine of x. There's the whole derivative there. So then we get into implicit. So first times the derivative of the second, plus the second times the derivative of the first. So there's the product rule on x to the third y, plus 2y dy dx, plus 1 is equal to 0. Don't forget to take the derivative of everything. If you go a little too fast, you'll leave it as 10, and then you won't be able to find the answer if this was multiple choice. So dy dx times x to the third plus 2y. So we'll factor out the dy dx. We'll get everything else to the other side. And then divide. So dy dx is equal to negative 1 minus 3x squared y over, I'm running out of room, x to the third plus 2y. Draw a possible graph of this situation. So second derivative is negative, so negative, that's equal to 0, and the function is negative. So if the function is negative, now we're only talking about very close to 0. If the function is negative, then we're at 0, negative something. If the first derivative is 0, that means it's a min or a max, and this says that the graph is concave down. So very close to 0, the graph looks like that. That's all I would really know. Now after that or before that, it could be doing different things, but at very close to 0, that's what we're told. So second derivative is concavity, first derivative is slope, and then the function value, of course. All right, if f of 3 is 6, f prime of 3 is 4, and f double prime of 3 is 6, what is the linear approximation of f of 3.2? So y minus 6 is equal to 4 times x minus 3. So we have the point, and we have the slope, and we don't need this for linear approximations. That's extra information just to throw us off. It didn't work. Didn't work. So instead of y, we usually write L of x is 6 plus 4 times x minus 3. Because we're doing the linearization. So y and L of x really means the same thing. So L of 3.2 is equal to 6 plus 4 times 3.2 minus 3. So 6 plus 4 times 0.2, that's 6.8. 6.8. So that's an approximation for our original function, but we don't know what the original function is. We used a line to approximate whatever the function was. The mean value theorem kind of versus what is the intermediate value theorem. The mean value theorem says if f of x is continuous on the closed interval and differentiable on the open interval, if that's the case, then C exists such that f prime of C is equal to f of b minus f of a over b minus a. So we have the conditions we have to meet in order to have a guarantee. Now, if we don't meet the conditions, that doesn't mean it won't happen. It means it's not guaranteed to happen. In other words, the average velocity should equal the instantaneous velocity. So in order for you to average 50 miles per hour, you had to have gone 50 miles per hour, at least for a brief moment in time during the trip. Now the intermediate value theorem says that, how should we say it? F takes on all values between x equals a and x equals b, if f is continuous. If f is continuous, f takes on all values between a and b. So that means if you have a here and b here, and f of a here and f of b, all the y values will be represented at least once. Could happen more. I mean, we could have more than that. This function could do this, but we don't know that. It could do this too. But we know that at least all of the values in between will be taken care of. We don't know anything outside of that. If f of 3 is 6 and f prime of 3 is 2, find f inverse prime of 6. So if f of 3 is 6, then f inverse of 6 is 3. That's inverses. How you find inverses? You switch the x's and the y's. Now, if f prime of 3 is 2, at the corresponding value, f inverse prime of 6 is equal to 1/2. So these are reciprocals of each other. So derivatives of inverse functions at their corresponding points are reciprocal. It doesn't say at the same point. It says corresponding points. That's why we use 3's here and 6's there. The figure to the left shows the graph of f prime of x, the derivative of the function f on the closed interval 1 to 7. The function is twice differentiable, and f of 1 is -3. Where are the points of inflection of f? Justify. So if this is f prime, then the points of inflection are where the second derivative is 0. So x equals 3 and x equals 5. Now, how do I know that? Well, f prime changes from increasing to decreasing, and then decreasing to increasing. So in other words, if the function is increasing, the slopes are positive. And the slope of the first derivative is the second derivative. So from positive to negative, then negative to positive, but we don't talk about slopes. We talk about the fact that f prime is increasing and then f prime is decreasing. It's switching. So there's the justification. Where are there, if any, a local minimum? Well, local minimums happen where the first derivative changes from local minimum, negative to positive. So right here, at x equals 6. X equals 6, how do I know that's a minimum? F prime changes from negative to positive. On what value does f reach its maximum value? We will have a much better answer for this later on, but right now, we know that f of 1 is -3. So we know that the function f starts right here. But now, if the slopes are negative to 0, what is the function doing? Should the function be increasing or decreasing? Decreasing, right? If the slopes are negative, if the first derivative is negative, the function's decreasing. Now we know that f prime is increasing, but that doesn't matter. We know that the original function is decreasing, and if the slopes of the f are positive, it's actually decreasing concave down, and then decreasing concave, concave up, and then concave down, and then concave up, but still decreasing all the way till we get there, all the way to 6. But then it increases a little bit. So after 6, this function increases a little bit. But I would venture to guess not nearly as much as it decreased. You guys agree with that? Probably decreased more than it increased. So where's the maximum value? Right at the beginning, because it didn't get back up to where it started because of all the decreasing. What value does f reach the maximum at x equals 1, right? Why? F decreases more than f increases. What a horrible, horrible answer to this. If we had already done, if we were past chapter 7, I would not accept that as an answer, and you wouldn't even consider it anymore. But right now, based on what we know, that's the best we can do. You just got to trust me. We can't skip ahead 2 chapters just for this one question. But we will be able to answer that a lot better later. But right now, that's fine. If g is defined as g of x equals x to the third f of x, find the slope of the tangent line to g at x equals 1. I promise you that I've given you the tools to do this problem. Give it a try. I promise you, you know everything you need to know to do this one. I don't think we've ever done one like this, though. All right, if you totally didn't get it, you'll have to, I don't know, just cross it out so you don't have, wrong answers. But if I said this, if I said f of x is equal to 3x squared minus 4, and I said, find the slope of the tangent line to that at x equals 1, what would you do? What would be the first step? Take the derivative, right? So that's actually what we're going to do here, except we don't have part of it. So g prime of x, the derivative, is equal to first times the derivative of the second plus the second times the derivative of the first. So there's the product rule. But we took the derivative. We have to know that we have 2 different functions, and we're taking the product rule of this. Well, now we just got to plug in all the values. So g prime of 1 is equal to 1. 1 to the third is 1. F prime of 1, we'll have to grab from the graph. F prime of 1 is negative 5. Negative 5. 1 squared is 1 again. And f of 1, they told that in the reading. That's why they gave us this right here. F of 1 is negative 3. So now we have negative 3. All right, so negative 5 minus 9, I'm looking at negative 14. You have all the tools to do that one. Now you just got to put it all together. And that's what makes this class kind of difficult, because I can't show you every possibility, every combination of every problem that AP could possibly give you. I can't do that. And I'm not going to do that. But I can give you the tools to solve every problem they give you. It's just going to it's going to take a little thinking to do. How are they asking this? What should I do? I promise you I'll give you all the tools. I won't show you every problem they could ask you. I can't. That's impossible. All right. A rectangle is inscribed in the region bounded by the x-axis and the parabola. Find the dimensions that give the largest rectangle. Well, our zeros are 9 and negative 9, and our highest point, the vertex, is up here at 81. So So we're going to inscribe a rectangle. Now we're trying to find the x. We don't know what that is. This is negative x over here, but that makes the base 2x. So the area is the length of 2 x's. The height is the function value. So if we knew the x, then this would be the x 81 minus x squared. This would be the y value, 81 minus x squared. So let's distribute 162x minus 2x to the third. A prime is 162 minus 6x squared. Set that equal to 0. And let me pause. This statement right here, that's a big deal. Setting it equal to 0 could either gain you a point, or if you don't set it equal to 0, it could lose you a point just for not writing that. Which seems trivial, but it's not. It's showing that you know that you're going to find the maximum when the derivative is equal to 0. So I encourage you to write that statement. You either will or you won't. All right, x squared is 27. So x is 3 square root of 3. I'm not going to worry about plus or minus because we're not worrying about negative distances on story problems, negative lengths. We don't deal with that. All right, so the dimensions, find the dimensions that give the largest rectangle. It's 3 square root of 3 by, now if I plug square root of 27 back into here, that becomes 27, and that's 54. 54. A cone, a conical tank is leaking from the bottom of the tank at a rate of 4 cubic feet per hour. So there's the cone. It's leaking out of the bottom, and we'll assume it looks like this. I don't think that would matter anyway. But I know that dV dt is equal to -4 because it's leaking. It's losing volume. It's not gaining volume. The tank has a base radius of 6. So the base radius is 6, and the height is 4. Over h is 4. So this is 6, this is 4, but we can write that proportion. Hey, thanks, bud. Everything okay? You all right and everything? Okay, very good. I bet. How fast is the height of the water in the tank falling? So what's dH dt? What's that? When the water level is at 2 feet. So when h is at that instant in time, right when h becomes 2, how fast is the level falling? So volume is 1/3 pi r squared h. But we would like to get rid of one of those variables. And so we really need to eliminate r because we're asked about h. So r is equal to 3/2 h. So volume now is going to change. We're going to change what it is. 3/2 h squared times another h. So we're trying to eliminate r now. We haven't done the calculus yet. Just trying to get rid of r, make it all into h. So 9/4. Let's just make it 9/12. And I could reduce that, but I'm not going to worry too about it. I'll worry about that later. You could do it now if you wanted to. dV, now we do the calculus. The derivative is equal to 3/12 is a fourth. 9/4 pi h squared dH dt. So the actual calculus starts right there. So we haven't done any calculus until right there, taking the derivative. Now we're still not doing calculus anymore. We're just plugging values in. So -4 is equal to 9/4 pi times 4, 2 squared, h squared, and then dH dt. Oh, 4 divided by 4 is 1. So if I divide that over, that's -1. And then -4 over 9 pi is the dH dt. But it says you got to be careful. How fast is the height of the water in the tank falling when the water level is at 2 feet? So the answer is 4 over 9 pi feet per hour. And if you leave it as a negative, I will not give you full credit. You'll get most of the credit. But if it was a multiple choice and one answer was positive and the other answer was negative, you would miss the whole thing. You'd do all that work and not get credit because you forgot about the negative stuff. Questions on that? Hopefully we've practiced that enough that it's fairly straightforward for you. If it's not, come on in after school, come on in before school on Monday. As I'm making this video, our test is on Monday. 6, I got some multiple choice to talk about. Derivative, implicitly. So the derivative of the outside here is cosine. But then we have to multiply times the derivative of the inside. So first times the derivative of the second, not dt, dy dx. I was used to doing that other problem, dy dx. Plus second times derivative of the first is equal to 1. So derivative of the outside times the derivative of the inside. Now we have to get dy dx by itself. So let's divide by the cosine. Minus the y over. And multiply by 1 over x. Or divide by x. But when you have a fraction like this, I think it's easier to see, we're multiplying by 1 over x kind of through the problem. So minus y over x. But if you look, we don't really have that answer on any of the choices. And the one thing I can do is common denominator. So we can multiply cosine of xy on top and bottom over here, and now we'll have the common denominator, and we'll get the answer, or one of the choices. So it looks like letter D is the choice there. Implicit. Let f be a function with a second derivative given by that. What are the x-coordinates of the points of inflection? So the possibilities are 0, 3, and 6. Let's throw that on a number line. Those are only potentials. So 0, 3, and 6. Just because they're making the second derivative equal to 0 does not mean they are points of inflection. And I'll get that every once in a while for justifications. Find the points of inflection, justify. Because the second derivative is equal to 0. No, that's not a justification. Those are possible points of inflection. Justification means they've actually changed concavity over those values. All right, so -1, 1, 4, and 7, let's say. So I plug -1 in. The x squared is not going to affect any signs because you square it, everything's going to be positive. So if I plug -1 in, it's a negative times a negative, concave up from negative infinity to 0. 1 is negative times a negative. That is also concave up. So no points of inflection there. 4 is positive times a negative. We got a point of inflection at 3. And then 7 is positive and positive. That's concave up. So 3 and 6 only. 3 and 6. 0 is not a point of inflection, even though it made the second derivative 0. Saying that 0 makes the second derivative 0 is not a justification for a point of inflection. It doesn't work that way. And I'll keep emphasizing that because that's a common justification for this. All right. The radius of a sphere is decreasing at a rate of 2 centimeters per second. radius decreasing 2. So dr dt is equal to negative 2. At the instant when the radius of the sphere is 3, when r is 3, what is the rate of change in square centimeters per second of the surface area? So what is ds dt? So there we've organized the information. I highly recommend you write that stuff down. Looking back through the problem takes more time than just taking the time to jot this stuff down. All right, they give us the formula, and they will on the AP test also. You're not asked to memorize too many formulas, or hardly any. Maybe you might use the Pythagorean theorem. They won't give you that. But I've never had a student come back and go, I would have done so much better hadn't I memorized a bunch of formulas. No one's ever said that. No one ever will. All right, so take the derivative, 8 pi r dr dt. So 8 pi times the radius is 3, and dr dt is negative 2. So 6 times 8 is 48. So negative 48 pi. They're nice to you. They made them all negative. So I would imagine the common mistake would be a positive 48 pi, not having dr dt as a negative. But they're nice to you. Questions on this one? Yeah, not the most exciting period you'll ever have. I just wanted to deliver everything I think you should need. So is everybody focused and staying awake at least a little bit? I know, I get it. I'd rather have you active, but I just want to get you the information. We're going to do the worksheet, we're going to check the answers, we're going to take the test, and we're going to nail it. The graph of the derivative of function f is shown in the figure above. The graph has horizontal tangent lines at negative 1, 1, and 3. At which of the following values of x does f have a relative maximum? Well, if this is f prime, that means the original function has a maximum where the derivative changes from positive to negative. I think that's the only place where f prime changes from positive to negative. So I'm looking at 4 only. That's where we have maximums, where the derivative changes from positive to negative. The graph of f prime, the derivative of f is shown above for negative 2 to 5. On what intervals is f increasing? I actually disagree with their answer, but I decided to leave this in. Let's read it again. The graph of f prime, the derivative, is shown on what intervals is f, the original function, where would that be increasing? So where do functions increase? Where the first derivative is positive. So where is this function positive? Or where is the derivative positive? According to their answers. What do you think? B? What do you think I have a problem with? It's a 0 in there, isn't it? Why didn't they skip over 1? I think they should have. Do you agree? I mean, I think they should have skipped over 1 because the function is not increasing or decreasing there. But if you're of the opinion that the 0 is where it stops increasing and then the 0 is where it starts increasing, then you would include it. I happen to disagree with that. So while their answer is right, I just happen to have a slight disagreement with it. But it's still correct. Oh, is that it? That's it. All right. It's all the fun I get.